All right, today we're going to go on a pretty incredible journey deep inside the human body. We're going to follow our food from the very first bite all the way to the end, exploring this amazing biological machine that turns a meal into the fuel that keeps us going. So let's dive in.
It's something we probably don't think about much, but have you ever really wondered how that happens? How does a sandwich actually become energy? The answer is this fascinating story of transformation, part mechanical crushing, part chemical wizardry, and it's all happening inside you automatically. So, how does it all work? So, this whole process happens inside what we call the digestive tract. Now, it might look like a complicated jumble of organs, but you can really just think of it as one long, super sophisticated tube that's about 7.5 meters long from start to finish. This is the path our food takes, and our tour is going to start right at the very top. And it all kicks off in the mouth. And this isn't just some simple doorway. No, it's a super active processing station where that whole disassembly process begins the second you take a bite.
Okay, so two really crucial things are happening here at the exact same time. First, you've got mechanical digestion. That's the physical stuff, your teeth grinding and tearing food into smaller pieces. But at the same time, chemical digestion starts up, using special molecules to break food down on a microscopic level.
Your teeth are doing the heavy lifting, obviously, but their tongue is just as important, moving that food around like a pro. And while all that is happening, your salivary glands are flooding the area with saliva. This mushy mix of chewed food and saliva creates a neat little package called a bolus, which is perfectly prepped for the next stage of its trip. And here's the cool part. That saliva isn't just water, it is loaded with a powerful enzyme called ptyalin. Now, ptyalin is a specialist. Its one and only job is to go after complex carbs, starches, the stuff in bread or potatoes, and it starts snipping them apart into simpler sugars. The chemical disassembly has officially started. So how do these enzymes actually work? Well, a great way to think about it is like a key that only fits one specific lock. Ptyalin, for example, is shaped to fit perfectly onto a starch molecule. Once it locks on, it acts just like a tiny pair of molecular scissors, snipping that big molecule into smaller pieces. Every enzyme in your body has a unique shape for a very unique job. All right, so once we swallow, that bolus gets pushed down a tube called the esophagus. Its next big stop is one of the most hostile environments in the entire body, the super acidic chamber of the stomach. The esophagus is pretty much just a muscular transit tube. But where it connects to the stomach, that's where things get really important. This connection is controlled by a muscular ring, a valve called the cardias. Think of the cardias as the gatekeeper to the stomach. It relaxes just long enough to let the bolus of food drop in, and then it immediately clamps shut. And this action is so important because it stops that powerful stomach acid from splashing back up into the esophagus, a feeling we all know as heartburn. So yeah, this little valve is a big deal. Okay. We're inside the stomach, and this is where the process really ramps up. The stomach wall has these powerful muscles that contract and churn, mixing and mashing everything up, continuing that mechanical breakdown. At the same time, the stomach lining is releasing gastric juices, like hydrochloric acid, which start to chemically dissolve the food into this thick, soupy mix. And just like the mouth, the stomach has its own specialist enzyme. This one's called pepsin. Now remember ptyalin worked on carbs? Well, pepsin is an expert at digesting protein. It absolutely loves the acidic environment in the stomach, and it gets right to work breaking down those big protein molecules from things like meat or beans into smaller chains. So after a few hours of all this churning and dissolving, what we once called food is now a substance called chyme. It's ready to move on, but it can't all go at once. The exit is guarded by another valve, the pylorus. It's another gatekeeper, and its job is to carefully release only small amounts of chyme into the next section at just the right pace. Leaving the stomach, we now enter the small intestine. And let me tell you, this is where the real magic of digestion happens. It's the main event for the chemical breakdown, and it's where the body is finally going to absorb all that fuel. This long, coiled tube is basically the hub of all the activity. This is where the final breakdown of everything, carbs, proteins, and fats, gets finished. And it doesn't work alone. It gets critical help from other organs, like the pancreas, which sends in a flood of new enzymes, and the liver, which sends in bile to help handle the fats. Look at this. The small intestine is just teeming with a whole team of new specialist enzymes. For example, you've got lactase, which specifically targets lactose, the sugar in milk. Then there's lipase, the fat digesting expert, breaking fats down into fatty acids. And maltase is there to finish the job that ptyalin started way back in the mouth, breaking down sugars into simple glucose, the body's #1 fuel source.
So at this point, the disassembly is basically complete. All that food has been broken down into its tiniest possible building blocks: simple sugars, amino acids, and fatty acids. But it's all completely useless if it just stays in this tube. Now it's time for the grand finale, getting those nutrients into the body. So, how on earth does the body absorb all this stuff so efficiently? The secret is surface area. You see, the inner wall of the small intestine isn't smooth at all. It's covered in millions and millions of these tiny, finger-like folds called villi. All of these little folds increase the surface area of the intestine so much that if you spread it all out, it would be about the size of a tennis court. Seriously. And this massive, sponge-like surface is packed with blood vessels. As those tiny nutrients drift by, they get absorbed through the villi and pass directly into the bloodstream, which then delivers them to every single cell in your body. So let's do a super quick recap of that whole incredible journey. It all starts in the mouth, then moves down to the stomach where proteins get hammered. It gets help from the liver and pancreas before the small intestine finishes the job and absorbs all the good stuff. And finally, the large intestine absorbs the remaining water and the process is complete. So, really, the next time you sit down to eat a meal, just take a moment to appreciate this silent, seamless, and unbelievably complex factory that's working inside you. It's a perfect system that turns simple food into the very essence of life itself. What an amazing piece of biological engineering.